Assalamu alaikum warahmatullah. So, it was basically the 10th test of the Gaash batch. So, I'm taking here the physics part of it, right? So, let's begin with the question number first. Question first is, when longitudinal wave propagates, what happens in the region of compressions and rarefactions? Compression and rarefaction is basically reason behind for the propagation of longitudinal waves. So during compression, particles come closer to each other. As a result of it, density of the particles is going to be, decrease, because it increases there because volume decrease, right? In case of rarefaction, in a region of rarefaction, particles are very far from one another. So as a result of it, volume increase, density decrease. So overall density basically varies, and density variation takes place in case of longitudinal wave propagation. So it is basically mentioned under option number first, okay? So under option first, basically, it is what I can call as density that varies, okay? Density is going to be vary in case of longitudinal wave propagation. So question second, traveling wave in a medium is given by the equation, the maximum acceleration of the particle. As you know, it from the theory of SHM, the maximum acceleration of the particle, magnitude of the maximum acceleration, it is basically a omega square, where a is amplitude and omega is angular frequency. So it's given under option number second. And the equation of wave is given by the displacement. If the displacement is 5 centimeter at t is equal to 0, then the total phase at t is equal to 7.5 seconds. Basically, we are asked to calculate the total phase, phi total, okay, of the particle at the time 7.5 seconds. How exactly we can do the question of this type? Just have a look here. Initial phase, I can represent it by phi naught, okay? So I can write it basically from the given equation. It is 2 pi upon 45 initial phase when time is 0 plus alpha. So it is going to be alpha, right? So initial phase of the particle is alpha. Now the phase of the particle at this particular time, I can write it phi, that's phi total, it is 2 pi upon 45, okay, times 7.5 times the phi naught. Now this initial phase we can compute it from the given data. Initially when t is equal to 0 seconds, displacement is 5, that's 10, and it is 0 sine of 0 plus alpha, okay? So it is basically sine of alpha, that I can write here sine of phi naught, that's 1 upon 2, okay? Because 5 by 10 is 1 upon 2. So phi naught must be equal to here 30 degree, that's pi upon 3, okay, sorry, pi upon 6 is basically what we can call as initial phase. So here I can write it as, it is 15 3s are, and it is 15 here, 0.5, 0.5 is 1 by 2, it will go with this. So here it is pi upon 3 plus pi upon 6, that is what the total phase is going to be come out here. It's pi upon 3, 1 plus 1 upon 2, that's 3 upon 2, 3 to jayega. So total phase at this time, that's 7.5 seconds. It's pi upon 2 is basically the total phase of the particle. Now here, pi upon 2 is basically shown under option number second is correct here. The intensity ratio of the two waves at the point is 4 upon 9, the amplitude is. As you know, intensity is basically proportional to the amplitude of the wave, right? Our amplitude is proportional to square root of intensity. So A1 upon A2 can be written as square root of I1 upon 2I2, that intensity ratio, that's given as 4 upon 9. So answer should be 2 upon 3, okay? 2 upon 3 is shown under option number second. Now a plane progressive wave is given by the displacement. What is the period of wave? We are asked to calculate basically the period of the wave. How exactly the period of wave will be just come out here. Say, we can just compare omega t with, and that's omega t, that's 6 point here, it's a multiplier, okay? 6.28 6.284 into 330 times t. T to jayega. It is 2 pi upon t by definition. So it is 6.284 into 330. So here t I can calculate as 2 into 3.14 upon 6.2844330. Okay. So I can calculate it further. T is that's 8, 2, and it is 6 here upon 6284 into 330. ये तो जाएगा t must be equal 1 upon 330 seconds. Okay, this must be the answer of question, and it is shown under option number first. Okay, so let's go and discuss one more question here. Transverse wave travels a taut steel wire with the velocity v when tension in the string is this. Now when the tension is changed to t, velocity changed to v upon 2, the value of t is here. You know, when we talk about the string and the speed of wave in the string is basically v is equal to square root of t upon mu, where t is tension that develops in the string and mu is basically mass per unit length. Okay, or I can say for the same string there is same mu and but tension will change. As a result, I am able to write this sort of proportionality here. So what I'm going to do, basically I have to calculate T is basically the tension in case second. Okay, so I can write it as T2 upon T1. It must be proportional to, or further I can write it as T will be proportional to V square. Okay, so here T will be some K times V square. Okay, now T2 upon T1, it will be K V2 square upon K V1 square, where K is some proportionality constant. So I will just cancel out it here. So what I'm getting further, T2 is here, T, that is something which I have to calculate here, right? Now यहाँ पे जो tension first case में है, that's 2.06 into 10 to the power 4. Here it is V2 is basically V upon 2 upon V, it is here square. ये तो जाएगा T जो है 2.06 10 to the power 4 upon 4, right? This is basically the thing that will give me the required answer of the question. Now अगर मैं इसी चीज को further solve करूंगा यहाँ पे, what I am getting here, I can write it 20.6 upon 4 in 10 to the power 3. Okay, I can write it like this way. So here it is 5.1 to something like into 10 to the power 3. So it is 5.1 this, and it is basically shown under option number second is basically here the correct option. So let's move to the question next. If we have to consider the wire with density rho stress sigma for the same density here, if the stress increases 2 times, okay, and then the speed of transverse wave along the wire changes by. Basically what we have to calculate here, I mean when the stress in the string is basically increased by 2 times, how exactly the speed will change. Just have a look. Again, I can write here the speed of wave in the string, right? That's square root of t upon mu, where the symbols have their usual meanings. But the question is going to be about in terms of stress and density. So here I can change this equation in terms of, I can write this equation in terms of stress and density. How? I can just, multiply here by A and divide by A. Mathematically, I can do this thing. Now here, you know, tension, it is basically the force upon area, that is stress, right? Upon mu upon A. Mu is mass per unit length times upon A, and that's mass upon length times A, okay? Mass upon length times A, and that's mass upon volume, that's what we can call as density. So V I can write here, stress upon the density, okay? Now this equation which I can use to get exactly what can be the velocity in case number second for the same string. Now just have a look here, density of the string is not going to change during stress, it will get 2 times. So I can write V2 upon V1 will be equal to, yes, this is going to be remain absent here. So before I can just look for the above ratio, here I can say it is going to be proportional to the square root of stress, because density जो है it will remain same during जब stress string में 2 times बढ़ जाएगा. Now here I can write it 2 times. Suppose करो string जो है stress in the string initially is S. Here I can write it this. So V2 जो है it is under root 2 times of V1, means that it will just change by the square root 2 times. Okay. Now it is shown basically under option number second that it will just increase by the square root 2 times. Okay. Now n, basically number of waves are produced in a string in 0.5 seconds. Now the tension in the string is doubled. Assume that the length and the radius is going to be remain constant, the number of waves produced in the string. Say number upon time, it is basically known as frequency, right? And we know the frequency, and here it is given as the same harmonic, okay? We know the frequency basically, it is related to the, what I can say, tension, okay? Yes. By the equation, it's I can write 1 upon 2L, while L is length of string. Here it is T upon mu, okay? Okay? And it is V basically, square root of T upon mu. Or I can say F, it will be proportional to the square root of temperature, okay? Sorry, square root of the tension. Now here, F2, or I can say F will be equal to some K times T, okay? Now here I can write F2 upon F1, it will be K times of T2 upon K times of T1, right? ये तो जाएगा F2 जो है, that's number of nodes. Let's assume it's n dash upon 0.5. Here it is n upon 0.5. Time is same in both the cases. So here we can write it further. T2, it's going to be get. Now tension in the string is doubled. Let's assume tension in case first is T. Now in tension in the case second will be 2 times as that of initial. So it will just go, ये जो जाएगा, n dash will be square root 2 times of n. And this is basically the answer of question. Now it is shown under option number second, okay? So let's go to the question next. Wave has a frequency and velocity. The phase difference between the points is 60. Phase difference, that's del phi, it is given here. 60 I can write in terms of pi radians, that's pi upon 3, okay? Now the part difference we have to calculate, and we know there exists well-known relation between phase difference and part difference. I can write it for a moment. Part difference, that's del, del I can write as lambda upon 2 pi times the path difference, that's del phi, okay? Now this path difference del, it is here lambda. Lambda I can compute here because speed of the wave is given as f times lambda. Lambda I can write v upon f, okay? And that's here lambda. So del, I can write lambda as v upon, here it is 1 upon 2 pi times del phi times lambda, that's v upon f. Delta phi तो हमने अभी लिया, यहाँ पे pi upon 3, here it is 2 pi. तो v क्या आएगा? v upon f जो है, the speed is 300, okay? Frequency is 500 hertz. So ये तो जाएगा, pi तो जाएगा. It is here 3 ones are 3 जाएगा. So it is 1 upon 10 meters. I can write it 100 centimeters, okay? ये तो जाएगा. So the path difference, that's del, it must be the 10 centimeters here in this particular question. So it is shown under option number first, okay? So here the plane progressive, the progressive wavelength along x represented by this, the wavelength at which the maximum particle velocity is 3 times the wave velocity. We know the wave velocity, okay? It is given as omega upon k, right? While omega is angular frequency and k, you know, it's a well-known parameter. That's what we can call as propagation number or wave number, whatever you can call it. Now here, here Vmax, the particle velocity, maximum particle velocity, that's amplitude times the angular frequency. It must be equal to 3 times the wave velocity. That's omega upon k. And this will go, k will be equal to 3 upon a, and k by definition, it's 2 pi upon lambda. Lambda I can compute here. That's 2 pi upon 3 times a, okay? This is basically the answer of question. And 2 upon 3 pi a, it is shown under option number 4. So the two waves of the same kind, of the same amplitude a, and superimpose at a point with the phase difference of wave between them, find the resultant. Basically two waves are given here with their amplitudes. One wave has amplitude a, another wave has amplitude a as well, and there is a part difference of, what you can say, if I will just use here what I can call as the phasor treatment, right? Under phasor treatment, we are going to show only amplitude. We treat the amplitude of wave as a vector under phasor treatment. So यहाँ पे amplitude जो है, आप a given wave, both the waves have indeed the same amplitude, right? Let's assume this is amplitude of first wave. Here this is, I can see the amplitude of second wave, right? But there is a phase difference of phi, okay? And this is A. Now, I can say here the resultant vector will be like this. Now, the magnitude of the resultant here is the resultant vector. Magnitude of the resultant vector, I can calculate it as like A square by using parallelogram law, A square plus 2A square cos of phi, okay? So, here it is 2a square 1 plus cos of phi. There is well-known trig formula. It's 1 plus cos theta is twice. So here r I can write as 2a square. That's 2 cos square phi upon 2, because this parameter is equal to this, right? That I have underlined it here. So it is 4a square cos square. So I can write it 2a cos phi upon 2, and it is basically the resultant amplitude of the wave, okay, after the superposition of two waves, and it is shown under option number 2, okay. Now, which of the following does not change as the wave moves from one medium to another medium? When basically wave is just going to propagate from one medium to another medium, there's a frequency that's not going to be altered, right? Frequency is not going to change. Why it's not going to change? It is basically the debatable issue, right? Why it's not going to change? And some people told basically it is just, I can say, the ratio. But this is not only the explanation why it is. So basically this ratio is remain constant. So as a result, we assume that the frequency does not change. And I told you this is not only the explanation, this is a debatable issue, I can say, okay? Anyway, so here it is. Two traveling waves and their displacements, they are going to be superimposed on a string, the distance between the adjacent antinodes. See, there are the two traveling waves with their displacements. Now, if I just look at the displacement of the wave first, if I want to know whether this is a right or left traveling wave, how exactly I can just look for it. In this argument, under sign, I can just compare simply to it 0, right? So here it is k as well. So kx will be equal to minus kct. It will just go out, it's minus ct, it's negative, means the displacement y1 of a wave, it must be the left traveling wave, okay? Now, in case second, y2, I have to just look over whether it is basically right or left. I will just, compare the argument of this sine function equal to 0. So x I can write as plus ct. When x is positive, that means it's a right traveling wave. If we have the two waves, one is right and another is left traveling, but with some common characters like frequency, okay, wave number and time and amplitude, they are common in both the waves, only there is a displacement, they are opposite to waves, and when these sort of displacements will superimpose, they will just form standing waves in a given string, right? Standing waveform is going to form in a given string. So as a result of it, we have the waveform like this. We have the waveform like this. Okay, we have the waveform like this. Okay, amplitude is same, time period is also same, frequency is also same, and but only difference is one is right traveling and another is left traveling. Okay, so in this particular case, this is going to be antinode and this is one of the antinode. Question part is basically we have to calculate the distance between the two antinodes that I represented by delta x. Okay, now I will just compute what is going to be the distance from this point, that's x1, and what's going to be the distance for the second antinode from the same origin, that's x2. Here I can compute this x2 like this way. Kx I can compare with omega t, okay? Kx I can compare with omega t because here displacement is going to be plotted against omega t, okay? Now here I can use this way to calculate x1 first of all, so it is omega, but the time here it is t half, for it is t, it must be t4, okay? So it is t4, omega is by definition 2 pi upon t, it is t4, so it is pi upon 2, okay? Kx1 is pi upon 2. What must be kx2? What must be kx2 here? Kx2 will be equal, again omega, that's 2 pi upon t here. From here to it is pi t by 2 plus t by 4. T by 2 plus t by 4, that's t by 2, it is 3 upon 2, that's 3t upon 4, okay? It is 3t upon 4, ये तो जाएगा यहाँ से, ये जाएगा, it is 3 pi upon 2, right? So finally what I got, kx1 and kx2, I will just make the difference up to, because I have to calculate delta x. Delta x, I assumed that it's a distance between two consecutive antinodes. So here I can say it's k x2 minus x1, that's 3 pi upon 2 minus pi upon 2. Can I say it's pi upon 2? Yes. So, sorry, it's 2 pi upon 2, so it is here pi. Now, x2 minus x1, that I assume it's delta x, and that was required. What I can say, here it is, I can say pi upon k is basically the distance between two adjacent antinodes, and it is shown under option number 4, okay? Now, standing wave formed is by the superposition of the two traveling waves in opposite directions. The transverse displacement is given this. What is the speed of traveling wave? Wave velocity or wave speed, I can say it's omega upon k. Omega, just compare omega with this, that's 200 pi upon k. K, I can say it is here this, okay? Kx, that's 5 pi upon 4, okay? Pi will go, here it is 40, okay? That's 40 into 4, that's 160 meters per second, right? 106 meters per second. It's shown under option number 2 is the answer here. Now, standing wave propagating with the velocity, this in an open pipe of length 4 meters has 4 nodes, the frequency of the wave. In an open pipe, basically 4 nodes are going to form, right? That means 4 times lambda half will give me the exact length of the pipe, that's L, and it's given as 4. 4 will go, lambda is equal to 2. And now when it comes to velocity, that's frequency times lambda, it is here 2. Frequency is here, yes. Sorry, we are called the frequency here. Here, frequency I can write V upon lambda, so V is given here 330 upon 2, and that's, I can say 165, okay, meters per second. 165, it must be here 300, I think. So we'll get here exactly 150 then, okay? Yes, 150 is basically the right answer of the question. Now, stretched string is vibrating in the second overtone. The number of nodes and antinodes between the ends of the string is. Basically, stretched string is going to vibrate, okay? This string is going to vibrate under second overtone. Second overtone means third harmonic, okay? Means third harmonic, okay? What we are basically asked to calculate? uh, the nodes between the ends, okay? See, wave function basically it nails down at the boundaries, right? So there is no basically displacement at the boundaries. So there is what I can call as node. But we have to just look over what can be the possible number of nodes in between two extremes, right, of a given string. How exactly we can do it? We know kx is basically n pi. You know where from this result is going to come out? We know it when we talk about the displacement of the stationary wave. It is 2a sine kx cos of omega t. It is a displacement of the stationary waveform, okay? So at extreme, when x is equal to L, basically displacement is going to be 0. That's only possible when KL is basically equal to n pi. You know, sine n pi, where n is 0, 1, 2, 3, and so on, is always 0, and displacement vanishes at the extreme. So when x is equal to L, now in this case, it is basically 2 pi upon lambda times L is equal to n pi. Now here, we are just cancelling some like vectors. N must be equal to here 2L upon lambda. I can use this equation here to solve the question, right? How? Let's see. So it vibrates under basically second over tune, that's third harmonic. For third harmonic, N must be equal to here 3. That's 2L is basically equal to 3 lambda, or L is 3 lambda upon 2. Okay, L is 3 lambda upon 2. If this is a string, it has lambda upon 2, lambda upon 2, lambda upon 2. It will just go up and it will form the waveform like this. Now here, this is, I mean, between the ends, nodes, number of nodes. This is 1, 2. 2 nodes are there, okay? Antinodes 1, 2, and 3. There are 3 antinodes, right? Right? Okay, 3 antinodes, 2 nodes and 3 antinodes. It is just shown under option number 2nd, okay? Now the length of open organ pipe is 2 times the length of another closed organ pipe. The fundamental frequency of the open organ pipe is F0 is given here. That's 100 hertz, right? Now what basically we are asked to calculate the frequency of third harmonic in the closed organ pipe. Frequency of third harmonic, that's F3, it is basically 3 V upon 4L. And when we discuss the harmonics of the closed pipe, it just come out like this. Here I'm just talking about the frequency, right? Now here it is 3V. But the closed pipe has, open pipe has the length 2 times. That means closed pipe should be have half length that of the open pipe. So here it is 3V upon 2L, and it is 3V upon 2L. You know, it is the fundamental frequency of open organ pipe. So it is 3V upon 2L is basically here 100, and it is 300 hertz, okay? 300 hertz is basically the frequency of third harmonic of closed organ pipe here. It is shown under option number 3rd. A resonance tube is resonated with the tuning fork of frequency this. We have got the resonance tube, right? And that has been resonated with this frequency, that's 380 hertz. 2 successive lengths of resonated ear column are found to be. This find the length of third resonance. We know the successive lengths in the resonating tube are lambda upon 2, it is 3 lambda upon 2, 5 lambda upon 2, 7 lambda upon 2, and so on. Okay? Now, I mean the difference between the 2 successive lengths, that's 3 lambda upon 2 minus lambda upon 2. It will be given as, and that's 50 minus 16. That's equal to 34. So it is here lambda upon 3 lambda upon 2 minus lambda upon 2. So lambda must be equal to here 34, okay? Lambda must be equal to here 34, and the length of third column here, and that is 5 lambda. It is here lambda upon 4, okay? It's 4 here basically, sorry. It's lambda upon 4. So here it should be 2 lambda upon 4, that's here 34. So it's lambda, and that is actually 68 centimeters, okay? Yes, 68 centimeters. Here it should be 5 lambda upon 4. It's a length of third resonance, that's 5 upon 4. Lambda is here 68, okay? It is 2 2s are, 2 3s are, 2 4s are. It is 2 1s are, 2 17s are. That's 5 into 17. It is 5, that's 3, 5, 1, that's 85 centimeters. It is basically the length of third resonance, and it is shown under option number first, okay? Now, the string oscillates according to the equation given. Find the distance between the nodes. We are basically asked to calculate what can be the distance between the nodes. It oscillates here, and we are asked to calculate here the distance between the nodes, okay? String displacement is like this, 0.50 centimeters, 7 pi x upon 3 and cos of 40 pi upon t. Now, basically when we talk about the waveform of the string like this, it goes like this way, okay? It goes like this way, and we are asked to calculate basically the distance between the nodes here, distance between the nodes, okay? How exactly we can calculate that distance? Yes, that means kx I can just compare with the omega t, okay? Yes, kx I can compare with the omega t. So x I can compute here, it is here 2 pi upon lambda, okay, times x is equal to omega t. Here it must be t upon 2 when I talk about these two nodes here. So it is here 2 pi upon t, here it is t upon 2, okay? So it will go, it is here pi will go here. So x I can call as, x is basically here lambda upon 2, okay, or lambda is here equal to 2x, okay? Yes, what can be the distance between the nodes? Here the displacement is given, and the distance between the nodes, here I can compute this 2 pi upon lambda is equal to here what that's pi upon 3, okay? Pi upon 3, pi will go, and lambda is equal to here 6, okay? Lambda is equal to here 6, that's equal to 2x, and x must be equal to here 3 centimeters, okay? So x is equal to 3 centimeters. It can be the corresponding distance between the nodes in this particular case, okay? And it is what I can call as answer of the question indeed. Now, if a closed organ pipe has length L1 in its fundamental mode resonates with an open organ pipe of length L2, then the ratio. Basically, at the fundamental node, at the fundamental frequency is going to match for the two tubes, two pipes, one is closed and another is open, and we know the fundamental frequency of closed organ pipe, okay, it is V upon 4L1, and the fundamental frequency of open organ pipe, that's V upon 2L2, okay? Now we can write it here, V upon 4L1 must be equal to V upon 12, because at resonance these two frequencies are going to match. Now here it is 2, it will go L1 upon L2, that's equal to 1:2. 1:2 is basically here the option of question. It is shown under option number first. The phenomena of beats can take place. We know they can take place in longitudinal as well as in transverse waves. Okay, it's just a theoretical question. An object is moving in a straight line with velocity goes past a stationary observer. The object emits a note, and it emits a frequency that's given as like this. And while moving, change in the frequency noted by the observer as object goes past him. Basically, object is moving and object has velocity here. That's how much 100, okay, and we can call it is the velocity of wave source, okay, and it goes past a stationary observer. Stationary observer, that means V naught is equal to here 0, change in the frequency. We are asked to calculate basically change in the frequency. How exactly we can do the question of this type? For that, I will use the equation that we already know in from the Doppler's effect. That's apparent frequency. It is V plus minus Vm plus minus V naught upon V plus minus Vm plus minus Vs times F. Okay? This is basically the general equation I can use, and this is the velocity of the medium. Medium is same in both the cases, and it's at rest, okay, and the observer is also at rest. But here what we need to do basically, apparent frequency we can calculate in case first, that's F prime, it must be V, and this object is going to be passed away, it moves passed away from the observer. Means the frequency heard by the observer, it will be less over the frequency, actual frequency of the wave source, okay? That means V, and it can be only less when I use here V plus Vs. Hope you must have got it, okay? Now V is given as 100, here it is F upon V is 100 plus it is 300 times, okay, here it is 400, okay, it is 400 volts. Now this is 400, it will go with this. F prime is basically the 100 hertz. But the question part जो है, हमें change in frequency यहाँ पे calculate करनी है. Delta F, that's F minus F prime. F is here 400 minus 100, that's going to be 300 hertz, okay, and it is shown under option number 2, right? So now the apparent frequency observed by the observer, moving observer away from the stationary source, is 20% less than the actual frequency. If the velocity of sound in air is 330 meters, then the velocity of observer is basically, again, we can just say F prime is equal to V plus minus V naught upon V plus minus Vs times F. Okay, F prime is basically what? This is an apparent frequency heard by the observer. It's less than. Means that it will heard 80% of actual frequency. That's V plus minus V naught by V plus minus Vs upon F. F to jayega, but source is here stationary, so Vs must be 0 here. 80% of F, that is 8 upon 10. Okay, V, and it is moving away from the, again if it's moving away, that means we have to take it negative, okay, because it will hear the less frequency, so it has to take negative here by the usual sign convention rules, okay, because it does not hear exact frequency of what we can call as observer frequency. It hears that's less over the exact frequency of wave train or wave source, so it may only be less if I will take here negative, okay. It's V naught, right? And this is V represents the speed of the wave train. So V naught, I can say it is V minus 8 upon 10, okay? V is here. If the speed of sound in air is basically how much? That's 330. So here it is, sorry. It is 8 upon 10, 8 upon 10, I can write it as usual, but here is V again. So it is 1 minus V naught upon V, okay? So V naught upon V is 1 minus 8 by 10, that's 2 by 10, that's 1 upon 5, okay? So V naught I can write as V upon 5. V is here 330 upon 5, okay? These are 5 6 are 5 6 are. So V naught, it must come out 66 meters per second, okay? So it is shown under option number 3. Option 3 is basically here the correct option of the question. Now, which of the following energy band diagram shows the N-type semiconductor? In N-type semiconductor, basically impurity level, it is below the conduction band, okay? Here it is conduction band, here it's valence band. It's not shown impurity level in conduction band. It is below here. We don't need to go and check it for another option. Here it's valence band, conduction band. So option second is basically here because impurity level lies below the conduction band in N-type semiconductor. Okay. And these are the number of holes and conduction electrons in an extrinsic semiconductor. So it's not shown here exact type, right? Whether it's N or P. Extrinsic means with impurity. So as a result, hole concentration and electron concentration is not same. So as a result, option 4 must be here the correct option. Which of the following statement is correct for the P-type? I mean, the number of holes in the conduction band, it's more than the number of holes in the valence band. This is wrong. Number of holes in the valence band is more over the number of holes in the conduction band at the room temperature. It is basically here the correct option, okay? Which of the following diode is reverse bias? Now here it's earth run, that's 0 minus P is here positive, it is negative, this is forward bias, okay? Here it is positive, this is 10, but this positive is more or negative again. This positive, it is again forward bias, okay? And this negative, it is 0 here, okay? Means this is going to be positive, this is going to be negative. So option third will be here the correct option, okay? Option third, and I don't know option fourth जो है, it is negative here, and but less negative means more positive, more negative means less positive. Here it can be treated as negative, positive, okay? Again it is forward bias, so only option remaining is here. Option third is under reverse bias, okay? It is reverse biased here. Option third must be here the correct option. Or find VB. Basically, we have to calculate the voltage drop across the resistor 10 ohm. Okay. Now, when you talk about the diode, it's in a forward bias condition, so it will just behave like the normal wire. Okay. Now, these two resistors are connected in parallel, right? And the play part of the diode is just it will just behave like normal wire because it is forward biased here. Okay. Now these two resistors are connected in parallels and their equivalent resistance must be 5 ohms. Okay, here it is 10, that's 15 upon 30. 30 upon 15, that means 2 amps current are going to be here, and after that the current will divide equally here. 1 amp will go along this and 1 amp will go along this. Okay, and we are potential, that's VAB, can be the resistance is 10 into current, that's 10 volt, okay? 10 volt will the potential drop across the resistor AB. So it is shown under option number first, okay? Now current I in the circuit. See, I current basically हमें पता करनी है. When you talk about this diode, it is a reverse bias, it's under reverse bias. So from here it will behave like open circuit, तो ये resistor काम ही नहीं करेगा. तब जाके ये जो diode है, it is forward bias, it will behave like normal wire. So what we are asked to calculate current. Current, these two resistors are right now in series. They are 50 upon 5 upon 50. That's 1 by 10, okay? 5 upon 50 is basically here the option. It is shown under option number second, okay? Now current in the given circuit, the current through the Zener diode. This is a Zener diode here, and the potential drop for it is basically 10. Now when it is 10, total potential is 15. Potential drop across this resistor must be the 5 volts, okay? Now what can be the current from this resistor, right? Yes, it must be V upon R, okay? And that's 5 upon 500, that's 1 upon 100, okay? Now basically current in the Zener diode, and what must be, what I can say, the current. Let's compute from here the current through this resistor. It will just contain the current, and the potential drop, because it is connected parallel to it, and it will just, it will have the same potential here, that's 10 upon 1500, okay? Okay, it's 10 upon 1500 here. So I can say it is 1 by 150 current एम्प्स जो है इस रजिस्टर के थ्रू, ठीक है ना। टोटल करंट जो है इतनी आती है, तो इस रजिस्टर के थ्रू इतनी है, ठीक है ना। इफ आई वांट टू नो करंट थ्रू द जीरो डायोड, total current minus this current will give me the current through the zero diode, right? That's total current 1 by 100 minus 1 by 150, okay? So here it is 1 upon 10, so it is 1 upon 10 minus 1 upon 15. So 1 upon 10, it is 15 minus 10 upon 150, okay? 15 minus 10, that is 5 upon 1500. It is 15, that's 1 by 300, 1 by 300, that is 0.33 into 10 to the power minus 2. So I can say here 3.3 into 10 to the power minus 3 amperes, or I can say it's 3.3 milliamps, okay? 3.3 milliamps is passing through the Zener diode, okay? Zener diode ke through itni current ja rahi hai, and it's shown under option number 4. That's the correct option here. Now, the direction of electric field in the p-n junction, if I will just talk about the p-n junction, okay? In p side, the majority charge carriers are holes, and in n side, if this is p and this is n, okay? But sort of depletion region is going to form near the junction, and over that depletion region, basically there is the majority charge carrier from here side that are holes, and majority charge carriers from here side. These are electrons, and electric field will be directed from N to P near the junction, okay? And it is shown under option second, from N to P side near the junction, and over this junction sort of fictitious barrier or battery is going to form, and that's this, okay? So let's move to the question next. There is a full wave rectifier circuit along with the input and output voltage is shown in the figure. The output due to the diode D2. D2 से क्या आउटपुट आएगा? देखो, अगर यहाँ पे ये पॉजिटिव है फर्स्ट हाफ साइकिल में, तो नेगेटिव हाफ साइकिल में डायोड D1 जो है रिवर्स बायस में है, कंडक्ट नहीं करेगा, तब जाके तो फर्स्ट डायोड तो कंडक्ट करेगा. इट शुड बी लुक लाइक दिस, ओके. नाउ जब पोलैरिटी चेंज हो जाएगी, ये बनेगा पॉजिटिव, ये नेगेटिव, तब जाके डायोड सेकंड जो है कंडक्ट करेगा, राइट. इट शुड गो लाइक दिस, and diode first conduct nahi karega. Now again polarity change, this becomes positive, this becomes negative, tab jaake diode D1 jo, this is rectification from D1, this is the rectification from D2, and this from D1, okay. Again when it become positive, this become negative, and we'll get just like this thing, it's from D2, okay. Now D2 jo hai, it will just A here, it will B, it will C, and it will B. Now, I mean, output waveform due to diode D2 will be equal to B and D, okay? B and D is basically written under option number second, so it is the correct option here. Now, in the given circuit, below represents which of the following logic operation. So, ये basically not gate act करेगा, या हम बोलेंगे inputs तो same है, that's A dot A, right? तो यहाँ पे जब जाएगा, it is again here, not gate, so it is here A dot whole complement, right? So it is A dot A, so it is what I can say AND gate, okay? It is AND, it represents here AND gate. Now the input Y in the given circuit, which of the following be correct? For input Y is equal to maximum, output, sorry, Y will be maximum. So in this case, what can be, what can be the values of A and B here? So A, it's what we can call as OR gate, and its Boolean algebra is A plus B here. Now it is here what I can call as AND gate. So it is first input here A plus B, second input C, right? If input C will be 0, whole of the output will be 0, okay? Okay. If input C will be 1, there is possibility output will be 1. If input C is 0, it is Y is 0, this is 0, Y will get 0. Only under option third, 1 plus 0, and that's 1, dot 1, that's 1, okay? Okay, option 4 must be here, the correct option. Question next. Here it is NOR gate, okay? Suppose these are inputs here, A and B, that's A plus B, whole complement, Okay, same input, it will just behave like NOT gate, that's A complement, whole complement. Here, again A plus B, okay. Now this is a NOT gate, we have this, and this algebra is again for the NOR gate, okay. It basically behave like what I can say the NOR gate here. Now in the given energy band diagram, the material should open circles and fill circles denote the holes, and in the valence band, basically holes are excess in number in case of p-type, okay? P-type semiconductor. So here it is, circles are going to be the holes, and these pillared circles denote basically electrons. So holes are larger in number in the valence band in case of, we know it's a p-type semiconductor, right? So option X, we have to just calculate what can be the output here. Look, this is A and this is here B complement. So it must be A dot B complement here. So here it is, I can say A complement, and this is B. Here must be A complement dot B. Now this is OR gate, so output will be the combination of two. So it's A dot B complement plus A complement dot B, right? This must be output here, A dot B complement. So it is shown under option number 2. And this is the answer of question. Also, in which of the output for all possible is expressed by the truth table, okay? Now let's just compute here the output here. So here it is NOR gate, so it is A plus B whole complement, okay? Okay, so here it's again NOR gate, so here it should look like Y must be A plus B, okay? Y must be, if one of the input is here maximum, output will be always maximum, because here I got Y as the sum of two inputs, right? If one of the input is here, this is algebra for OR gate. It will behave like OR gate. If one input is here, both the inputs are 0, output will be 0. Both the inputs of one input is 1. If one of the inputs is here maximum, output must be maximum, okay? So option first is basically here the correct option, right? Which of the following diodes which are in forward bias? See, here it is 10, that's plus. Here it is 5, so it is a forward bias. A is forward bias, okay? Now B is here at 0, negative, it is reverse bias, okay? So here is negative, that's less negative, more negative. Again, it is a forward bias here. So it is positive, it is 0, it is 5, okay? So it is reverse bias here, reverse bias. So A and C are forward bias. Basically, A and C are here the forward bias. Option third is correct option. In an N-type semiconductor, which of the following statement is true? Holes are the majority carriers, and N-type semiconductor में basically electrons होते हैं majority charge carriers, okay? So option first is wrong. Electrons are the majority charge carriers, and trivalent atoms are dopants. No, electrons are minority charge carriers, and pentavalent are, holes are minority carriers, and pentavalent atom are dopants. Option 4 is basically here the correct option, right? In N-type, hole concentration is less over electron concentration. For N-type, NH is less than an electron, okay? And basically these electrons are, when we use the dopants, we use the dopants of pentavalent, okay? And a phosphorus type of impurity we are going to use to create more number of electrons in case of N-type semiconductor. So option 4 is here the correct option. So which of the following gate is represented below? So look, this is here input A, that's low from the given graphics, and this is input B, okay, that's again low. So the result output is again low, okay? When we talk about AND gate, A dot B, both the inputs, if both the inputs are low, output must be low, okay? So here, for case second, input in A is high, and again, input B is here low, high, low, it must be low here. It is said that it is low, result is here low again, okay? And that means it follows so far the AND gate property, right? Okay, now again the input A is here, low, and output B is again here low. The result is also low. It also, so far it follows the property of AND gate. Here output is high, input is high, A input is high, B input is what I can call as low. So again it's low, right? So it follows the property of AND gate so far. Now here A input is basically, so A input is high, B input is low, right? Again the output is here low, so it forms basically here AND gate, okay? Now the given circuit has two ideal diodes connected as shown in figure below. The current through the resistor R1 will be. Here it is basically the resistor R1 and we are asked to calculate the current. See, when we talk about the diode D1, it is reverse biased. So from here, it will just behave like open circuit. Now this diode D2, it will in forward bias condition, so it will behave like the normal wire. Now these two resistors are connected in series, so it is 10 upon 4, that's 2.5 will be the current through the each resistor, that's R1 and R2, because they are connected in series, right? So current must be here 2.5 amperes. So here for a given transistor circuit VBE, base emitter voltage is 0.5, find IE. So here it is 5, base emitter is going to be 5, here it is. So if I use the Kirchhoff's law, that's 5 minus 0.7, 5 minus 0.7, it is equal to IR times the resistance, that's equal to here 2 in 10 to the power 3, okay? So it is 4.3, right? 4.3 is equal to IR into 3, 10 to the power 3, 2 into 10 to the power. So IR will be equal to here 4.3 upon 2, 4.3 upon 2 in 10 to the power minus 3, that's 2.12 something like, that's 2.2 milliamperes mainly. So it is shown under option number second will be the correct option here. Now find out the value of y here. We are asked to calculate the value of y. So it is A, B, so here it must be A plus B here. So here it should be B dot. So again it's an OR gate, that's B complement plus C. Now it's AND gate, that's A plus B dot B complement plus C. Okay, any algebra here? Yes, A plus B, B complement plus C. It is under option number second. So option second is correct option here. Now the 4 wires of identical lengths, diameter and the material are structured on a sonometer box. The ratio of the tensions is like this, the ratio of the fundamental frequencies. We know the fundamental frequency in the sonometer box, there is a string like this connected at the both ends, so we have the harmonics like this, okay? Okay, and the frequency I can say it is proportional to the square root of here the tension, so F1 is to F2 is to F3 is to F4, it must be equal to under root of T1 is to T2 is to T3 is to T4, okay? Under root of T1, so that's 1, so it is here 1. Under root of T2, that's 4, so it must be equal to here 2. T3, that's 9, it must be equal to 3. T4, 16, it must be equal to 4. 1, 2, 3 is to 4. So here it is shown under option number third is basically here the correct option, right? So it was all about this part. Thank you.